Hello students, let us discuss ionic bond in the chapter Chemical Bonding and Molecular Structure. As we have already discussed about the octet rule, that the atom in order to get stable, atom can gain the electron or by losing all its valence electron. When the complete transfer of one or more electrons from one atom to another atom takes place, an ionic or electrovalent bond is formed. This type of bond is generally formed when the metallic atom combines with non-metallic atom. So let us discuss ionic bond with the help of an example. Sodium belongs to group 1. It easily loses one electron and form sodium ion. When you look at the configuration, that is the configuration here, the outermost electron is in third shell, that is in 3s orbital. It loses that electron and now it comes to the stable configuration, that is a noble gas configuration. Similarly, the halogen, chlorine here, it have a 7 electron in the valence shell, that is in the outermost shell it have 7 electron. So in order to obtain a stable configuration, that is in order to complete the octet, it easily gain 1 electron and it form chloride ion. When you look at the configuration here, this configuration is the configuration of chlorine, and with the gain of electron, now its configuration comes to a stable configuration of argon. So we can conclude that here the atoms like alkali metals, which is electropositive in nature, they usually lose the electron to attain a stable configuration, and the electronegative elements like halogen usually gain the electron in order to obtain a stable configuration. Let us take another example. Calcium, it belongs to group 2nd. It have 2 electron in the outermost shell, so it loses 2 electron. Look at the equation, how it is written. Ca give rise to Ca2 plus 2 electron. When the electron is written on the right side of the equation, it shows that it is given out. When the electron is written on the left side of the equation, it shows that it is gained. So in the case of fluorine, F plus electron, that is F gain the electron to give F negative. So what is formed here? The two ions that is formed, that is calcium ion Ca2 plus and F negative. One is positive charge, other one is negative charge. So definitely there will be a force of attraction between them, that is electrostatic force of attraction. So we can say that the bond formed as a result of electrostatic attraction between the positive and negative ions was termed as electrovalent bond. Here the electrovalence is thus equal to the number of unit charge on the ion. Like the case of calcium, calcium having 2 plus charge. So what is the electrovalence? That is the 2 positive is the electrovalence. So calcium is assigned as a positive electrovalence of 2. So what is the electrovalence for calcium? That is a positive electrovalence of 2. But chlorine, that is Cl minus, it have 1 negative charge. So the electrovalence for chlorine is a negative electrovalence of 1, that is minus 1. So this is actually the force of attraction between the positive and negatively charged ions that is formed due to the loss of electron, that positive charge is formed, and gain of electron result in the negatively charged ion. Let us take the general equation. The metal loses 1 electron to form positively charged ion, that is cation. This process is called as a removal of electron. The energy change, the enthalpy change involved here is called as ionization enthalpy. That is a enthalpy change during the loss of electron. In the case of halogens, it gain electron to form an ion. The enthalpy change here, it is electron gain enthalpy. So here the positively charged and negatively charged ions are formed that result in the formation of the compound MX, that is a ionic compound here. So obviously the ionic bond will be formed more easily between the elements with comparatively low ionization enthalpy and the elements with the comparatively high negative value of electron gain enthalpy, because here the energy change, that is ionization enthalpy, here is the electron gain enthalpy. So when low is the value of ionization enthalpy, easy will be the formation of positively charged ion. And when there is a high negative of electron gain enthalpy, then easily it forms the negative charged ion. So we can say that the ionic bond is formed when there is a removal of electron from the metal and when there is a gain of electron of halogen that result in the formation of ionic bond. So the energy change which is involved here, that is ionization enthalpy and electron gain enthalpy. So obviously the ionic bond which is formed will be more easily takes place when there is low ionization enthalpy and comparatively high negative value of electron gain enthalpy. So the bond formation takes place easily. Ionic compound in the crystalline state consists of orderly three-dimensional arrangement of cations and anions held together by Coulombic interaction energies. Just like the case of table salt NaCl, here the cation, that is Na plus, and the anion, that is Cl minus, they are orderly arranged in a three-dimensional way as shown in the figure here. These compounds crystallize in a different crystal structures determined by the size of the ion, their packing arrangement and other factors. So this is the crystal structure of sodium chloride, that is a rock salt, which is shown here. So the detail of these type of arrangement will be going to discussed in the 12th standard chapter solid state. So that is all about the ionic bond. In this video we discussed about the ionic bond and some examples. So have a nice day.